Hi guys, today we're going to talk about the remainder and factor theorems. So I just want to state them first and then we'll go through them. The remainder theorem states if a polynomial f of x is divided by x minus c, then the remainder is f of c. Okay, so all that's telling me is if I take this and set it equal to 0, so x minus c equals 0, I would get c, a positive c. And I then plug that into the equation for f of x, the result is my remainder. Okay, so that's all it's saying, is I don't need to do division for this. I'm going to be plugging numbers into an equation, and the number that comes out is going to be my remainder. So then the factor theorem states that a polynomial function f of x has a linear factor x minus a. They're using a this time, not c. If and only if f of a equals 0. So what that's saying is if I do what the remainder theorem tells me to do, set this equal to 0, get positive a, plug positive a in, and I get 0, then it is a factor. If I do not get 0, then it's not a factor. This statement right here, the if and only if statement, is an extremely strong statement. It only happens if I plug it in and I get 0. Then it is a factor. If I do not plug it in and get a 0, then it is not a factor. Okay? So let's look at a few problems. The first one I want to look at is this one. We're going to use the remainder theorem. Okay? So find the remainder without division. So we're not going to divide. Okay? So I have 2x to the 4th plus 4x cubed plus 5x minus 6 is divided by x plus 3. So if I took my x plus 3 and set it equal to 0, I would subtract 3 off of both sides. You're going to tell me x is equal to negative 3. I'm going to plug negative 3 into my equation. So this is 2 times negative 3 to the 4th plus 4 times negative 3 to the 3rd plus 5 times negative 3 minus 6. And then we're just going to simplify that. So we're going to do the math. Okay. Let's see. 3 to the 4th power, or negative 3, I'm sorry, to the 4th power is 81. So this is 2 times 81 plus 4 times negative 3 to the 3rd power is negative 27. That's minus 15 minus 6. 2 times 8 is 16. 4 times a negative 27 is going to be a negative 108. And that's minus 21. So then 16 minus 108 minus 21. I'm going to get a negative 113. Okay, so that's my remainder. Let's double check everything. Oh, nope. What did I do? I apologize. This is 81. That doesn't look right. I didn't think that looked right. Let's correct that. 2 times 81. That's 162. Let's do 162 minus 108 minus 21. Let's correct that. That should be 33. Much better. So my remainder, if I were to divide that polynomial, this polynomial right here, by this, my remainder would be 33. Okay? So I know that going into it. So now if we try to do this one, and I know a lot of you are panicking when you're looking at the numbers, because it's x to the 79th plus 3x to the 24th plus 5. Nobody wants to do the division on this. It would be long and hard. And so I just want to know what the remainder is. So again, come over here. X minus 1 equals 0. Add 1 to both sides. X would be 1. I just want you to plug 1 into that equation. So it's going to be 1. Oops, that should be in yellow. Make him yellow. To the 79th plus 3 times 1 to the 24th power plus 5. Okay. 1 to the 79th power is 1 plus 3 times 1 to the 24th power is 1 plus 5. This is 1 plus 3 plus 5. And that's going to be 4 and 5. That's 9. Okay, so that's only going to end up being 9. So I now know that if I were to divide this, I would have a remainder of 9. Now, to feed into the next part of this, I also know this is not a factor of this because I get a remainder. If that remainder had worked out to be 0, then yes, it is a factor. But because it did not, no, it is not. So again, let's look at some of those with the factor theorems. So now we're going to use the factor theorem. I just want you to determine if x minus 3 and x plus 1 are factors of that polynomial. So we could divide and see if it goes into it evenly, or we can just, all I want to know is it a factor, yes or no? So I know when I'm doing x minus 3, I'd want to plug in a 3. And if I was doing x plus 1, I'd want to plug in a negative 1. So let's just plug those numbers in and see what happens. So this is 3 cubed minus 4 times 3 squared plus 2 times 3 plus 3. All right, so let's do this. 3 cubed is 27. This is 4 times, that's 9, plus 6 plus 3. This is 27. And then 4 times 9 is going to be 36, so minus 36. And I can add those together, plus 9. Add these numbers together, 27 minus 36 plus 9. And I get 0. So, yes. Whoops, I don't know what I just did. I apologize. There we go. All right, so then yes, this one is a factor. Yes, that's a factor. Let's see if x plus 1 is also a factor. All right, so let's go here. Let's look at this again. This is cubed minus 4 squared plus 2 times a number plus 3. And we are plugging in negative 1 across the board. So this is going to be minus 1 minus 4 times 1 minus 2 plus 3. This is minus 1 minus 4 plus 1. I get negative 4, so no, that one is not a factor. So this one was yes. This one's no. Very simple. This one worked out to be 0. This one did not. Okay, so that's a factor. This one is not. So if I was trying to divide it to make it smaller, I'd want to use my factor, not the one that was. Try this one. All right, so again, if I plug this one in, it's negative 1. If I do this one, it is 2. I have x cubed plus 5x squared minus 2 times x minus 24. Plug negative 1 in for everyone. It's going to give me negative 1 plus 5 times 1 plus 2 minus 24. That's a negative 1 plus 5 minus 22. All right, yes, and this is going to be negative 1 plus 5 minus 22. Nope, let's try that again. Is negative 36. So no, not a factor. Okay, let's try the other one. So again, cubed plus 5 times x squared minus 2 times x minus 24. This time we're going to put in 2. And we are going to get that's 8 plus 5 times 4 minus 4 minus 24. That's 8 plus 20 minus 28. And that works out to be 0. So yes, it is a factor. Okay. So it's pretty much straightforward this week. Easier on the work. We're just plugging in numbers. If you need help with anything, let me know. Email me, join our Google Meets. If you're in class, ask questions. I'll go over it with you on the board. If you come to the Google Meet, I will be able to demonstrate it to you there. Come to after school assistance. There's plenty of ways for you guys to get help so we can get the work turned in on time. Just to let you know, this week is progress reports. So we're at the middle of the marking period. So please make sure all your work is getting turned in. Thanks, guys. Have a good week.